Good morning. Today I'm going to be talking about a math lesson that I did using curriculum-based dynamic assessment. So the math lesson was for a ninth grade class, and I focused on a single student called Rahim to assess his progress throughout this lesson. The point of the lesson, was to begin to look at how growth and decay patterns work. Students had already learned about functions. They'd already seen about graphing a line. However, they hadn't really applied it to real-world situations. So the overarching point of the entire unit was that growth and decay patterns exist in the world, and they inform a lot of our opinions. So they were kind of just building on that background knowledge. And then they were beginning to look at nonlinear functions such as exponential functions and inverse variation. So to build background knowledge at first, it was kind of just like a little discussion. We just told the class to discuss growth patterns, and that was it. So students came up with really great examples. They talked about stock market patterns and investors looking at those to figure out where to invest their stock. They talked about McDonald's using growth patterns to monitor when customers come in and then determining how many people to put on a shift or how much food to buy for that shift. And they began to make really great connections there. So since this was dynamic assessment, I actually didn't give too much direct instruction. I worked with function machines, which will come up on the screen in just a second, and that was just to activate their prior knowledge on functions. So they already had known that when you plug in something for x, you will get a y out. So they had to look at machines where they would drop a value for x in the top of a machine, and then it would go through a couple machines and come out at the end. So students grasped that pretty easily because that was not really much of a challenge. However, I used that assessment to figure out where students need help. So I used that to inform my groupings for the next challenge. And the next challenge was to design a function machine where I gave them 4 equations and they had to get a desired output. So I told them that if they put 15 in the first machine, after this equation went through all 4 machines, they needed to come out with a -6 as an answer. Then we did another thing, which order would result in a final output of 2 when the first input is 8. And so what I did in this one is I kind of just let students, since I had put them in heterogeneous groups, I let them kind of talk it out with their groups. A lot of them got a little bit stuck, and I made sure that I asked them questions just to really activate prior knowledge, and some critical thinking questions. So for example, one of the equations has a x minus 2 squared. So they know that if you're squaring a number, you're going to end up with a large number. Another of the equations had a negative absolute value. So they knew that the absolute value of a number is always positive. However, since there's a negative sign in front of the absolute value symbol, they were able to make the connection that they're multiplying the absolute value by a -1. That meant that they would always get a negative answer. So that helped them figure out a little bit on how they were able to make those connections. So after day 1, I gave them just a really quick application problem. And again, it was a function machine. So it was just looking at 2 machines and trying to figure out the input and output. So students were pretty successful with that. So I again used that to inform my groupings for the second day. On the second day, students actually began to work on labs. So they had a hot tub design lab. There was a local crisis lab, which they really liked because this one had to do with the spread of disease, so they thought it was very relevant. And then there was another lab about writing their own signature and how long it would take to do that. So for the first lab, it was kind of simple. They had to design a hot tub that this guy wants to locate behind his house. He has 36 tiles and he needs to use them. He needs to use all of them to make a rectangular tub. So basically, this was just factoring. However, a lot of the students didn't figure that out at first. And then they figured the growth pattern came as an inverse variation. For the local crisis, Lab B, there was a real-world scenario about health officials trying to control an outbreak of the flu. So there was 2 people that were sick, and then on each day they infected 2 more people. So students saw an exponential relationship and were able to see that while the line went up slowly at first, it sort of jumped and it began to increase exponentially. they saw that this was way different than a linear equation, and they were able to make the connection that in real-world situations, with the spread of disease, of course, like, it's always an exponential. So this is an example of data representation for the local crisis, where they should have seen a very high increase. So after this, the students had to just graph their data in a table and on a graph. I had not told them this before, so they were already sort of intuitively making tables, which was wonderful. However, I was really curious to see if students were able to do this. Overall, again, students were very helpful. I gave limited interventions. Most of the interventions that I gave was that I may have like hinted to groups that maybe a nice way to organize your data would be to use a table. And I may have hinted to groups to use the manipulatives. For example, in Lab B, the local crisis, students were actually able to use beans to represent the people, and that made them, that kind of made the connection a little bit more. It made it a little bit less abstract. So my reasoning behind this is that students work best in their zone of proximal development. They were pushed in this lesson, and they were like really struggling, but they actually pretty much all were pretty successful. So on the second day, I decided to ask them some analysis questions, and this was the post-assessment to see how well they actually understood the lesson. So they had already looked at growth patterns, and they already realized and saw and noticed that the graphs all were different. However, we never really spoke about it. So the analysis questions, we asked which data was linear, and they were able to inform me on which data created a line. That was the handwriting graph. So they were able to make the connection that if you're writing your signature and it takes you 1 second to write your name one time, then it should take you 2 seconds to write it next time and 3 seconds to write it 3 times, and so on and so forth. There was a critical thinking question where we talked about the flu vaccine being available only after a certain point. Students needed to make connections and figure out which graph or table was easier to answer this question. We had another question that was about the hot tub designer wanting to create, he had like the smallest backyard, so he wanted to create a tub with the smallest perimeter, which got us into an argument about if a square was a rectangle or a rectangle was a square, which was very interesting. And then lastly, another kind of simpler analysis question. So on their lab A, which was the hot tub design, they had graphed X as the width and Y as the height, or length, I'm sorry. So we asked them if there could be a point for X equals 0 on lab A, and the answer was no, and they all were able to figure that out because, of course, if you have a length of 0, that means that your real-world thing does not exist.